All right, so here it asks for finding the absolute max and min over, and this is the key thing to notice, that it is in fact a closed interval. So when you see that closed interval, we know we need critical numbers, and then we need to compare the y values. So what we're going to do is we're going to first find our critical numbers. So here I have my derivative. The negative 7x is a linear term, so that just goes to negative 7. The negative 8 is a standalone constant, so it goes to 0. Now, here is something a little different. What you're seeing is that you just have a constant. If you set that equal to 0, there's no x there to solve for. So because there's no x to solve, there's going to be no critical numbers. So usually what we did is we plugged into our original function, and when we plugged into our original function, you'll remember we plugged in critical numbers and the endpoints. Here, we don't have a critical number to plug in. So that means we're just going to plug the endpoints in. We're just going to plug in the -2 or -1 and the 2 into that original function. So what we'll do is we'll plug in -1 first, and that's going to give us a positive 7 minus 8, so that gives us -1, and then we'll plug in our 2, so -7 times 2 minus 8, so that's going to give us a -14 minus an 8 is going to give us a -22. And then we compare these y values. So the smaller y value here is the -22. That's going to be your absolute min. And then the larger y value is the -1. That is our absolute max. So our absolute max is -1. That occurs at -1. And then the absolute min is -22, and that occurs at 2.